So it's not in standard form. For me, sometimes that's a yay that it's not in standard form. Because to find the x and y intercepts, it's a pain in standard form. However, to find the vertex, well, even then, it's just a pain. It can go either way on you. Okay. So this is our old parabola, and how does he open? How does he open? He opens right. He opens right because A is positive. Now we've got to play the game with the vertex, because remember, standard form for this guy is x equals a times y minus k squared plus h. Right, so now we're looking not for the x-coordinate of the vertex, but the y-coordinate of the vertex. So the y-coordinate of the vertex is minus b over 2a, which is minus 4 over 2 times 2. Oh, isn't that cute? Which is negative 1. I like that. But that's the y-coordinate of the vertex. But you always write it as an xy coordinate point. And then the x-coordinate of the vertex, I plug it into my formula, which is 2 times negative 1 squared plus 4 times negative 1 plus 5, which is 2 times 1 minus 4 plus 5, which is 7 minus 4, or 3. So we have the vertex. The vertex is at x equal 3, y equal negative 1. And he opens to the, which tells you, am I going to have x-intercepts? Or y-intercepts, excuse me. It's going to cut the x-axis, but it's not going to cut the y-axis. Yeah. What's the axis of symmetry? Well, it's a y equal, since it runs left to right, it's horizontal. So it's y equal negative 1. So it goes right through the x-coordinate of that or y-coordinate of that vertex. So that's the AOS. And now x-intercepts, if they exist, that's where y is 0. So that means x is 2 times 0 squared plus 4 times 0 plus 5. So that means x is 5. So it's going to be 5, 0. Right there. Now, I can use symmetry to get the other coordinate point, because this is 1 unit from the AOS. And that means if I go down to the other side 1 unit from the AOS, I'd have 2 points, and you can graph your parabola. Well, we're still going to go after the y-intercepts. We know they don't exist, but that says that x equals 0. And so this says that 0 equals 2y squared plus 4y plus 5. And then you look to factor, and the thing doesn't factor. Those are all pluses. The lowest number I could get is a 7. So that's when you say, oh, I'll use a quadratic formula. And so it's y is equal to minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So yes, we can use the quadratic formula for this stuff, which is minus 4 plus or minus. This is going to be 16 minus 8 times 5 is 40 all over 4. And what you do notice that these are imaginary. That's why we don't have any. So there's none. That means we need an additional point. And this would be unpleasant. Well, not necessarily, because we can put in y and get out x. So we can pick our y value. So I need an extra point. And the reason why this works out so well is all I would need to do is I would need to put in a point. If this is the AOS and that's y equal -1, I pick a y value that is smaller than -1. I already have the other side, so I know this guy's going to be like that and keep going. I need his other half. So I need to pick a y value smaller than -1, so just pick y equal -2. So that means that x, if y equals -2, then x is 2 times -2 squared plus 4 times -2 plus 5, which is 2 times 4, or 8. 4 times -2, -8, plus 5. So x is 5. So it's 5, -2. So x is 5, y is -2. Right there. And you have the other half. This is where geometry sometimes comes into play when you're trying to graph these things. It just is, you got to keep in mind, what does the thing look like? And since you're putting in y's and getting out x, you need to pick your y values. What do you need? What do you already have? That's your saving grace on these guys.